Hello everyone, welcome back to our channel. So today we are going to discuss another problem from the range query problem set, that is the hotel queries. So let's understand what the problem statement is saying. So the problem is saying we are given with n hotels on the street and each hotel has the number of free rooms, and your task is to assign the hotel rooms to a group of tourists. And what are the conditions of tourists that we are given? A group will come one after the another and following, okay, and following hotel, okay. So yeah, so let's understand the problem statement, what it's saying, and then we'll move into the solution of how we could approach this problem. So the problem is saying, let's suppose we have 8 hotels and there are free rooms in hotels. Now tourists came, let's suppose T tourists came. For each tourist T of I, they are saying we need to find an H of J which is greater than equal to T of I. Means when a tourist came, they want that we need a hotel room with at least TI free rooms. So we need to find a hotel J which has greater than equal to T of I, and we need to find it for all the tourists. And if there is a hotel room, we should print that hotel, and if not, then we should print the 0. So let's understand this with an sample test case. So sample test case is this: 3 2 4 1 5 5 2 6, and tourists are 4 4 7 1. So we are given with 8 hotels and tourists are 5, and this is what they want. So they are saying, so first tourist, when the first tourist group came in, they said we need 4 free rooms. So if we traverse from the starting side, 3 is less than 4, 2 is less than 4, and 4 is, we got 4 rooms here. So we print the first. So for first tourist we can give hotel 3 to them, okay, and we would decrease now the free room for this, it would reduce to 0. So now our hotel would look something like 3 2 0 1 5 5 2 and 6. Now when the second tourist group came, it needs 4 rooms, sorry. So for these 4 rooms we'll find the next, that is this fifth. So 1 2 3 4 and fifth, so this fifth would come, and this would reduce to 1. Same for this 7, we actually have no hotel free room, so this would be 0. And for this 1, this first hotel could be given, and for this, and the count reduced to 2. And for this one also, first hotel could be given. So yeah, so this is how our final answer would look like. Let's see. Yeah, it's 350011. Now let's discuss the solution, like how we could actually approach this problem. So the first approach that comes to mind is the naive approach. Like for every group, I'll traverse for each hotel if g of I, sorry, if h of I is greater than or equal to g of j, then I'll print that I and reduce h of I minus equal to g of j. But what is the time complexity of this solution? Let's suppose we have n hotels and n tourist groups. So our time complexity is O of n into m, which would actually give us a TLE, like as it's a brute force solution, and our constraints are 10 raised to power 5, so yeah, this won't get accepted. Now let's discuss the optimized approach. What if I say, if I can find the next hotel with available rooms in log n time, and then update the hotels in log n time, would that be a possible, so would that give me a good solution. So this would actually be a highly accurate solution. Now let's see how we can actually reduce the next hotel time, and time of like next find the next available hotel and update as well. For this we would be using the segment trees. Yeah, so we would be making a max segment tree. We would be storing the max between all the groups, because we need to find the maximum number of rooms available in a particular group from 0 to I. Maximum, what is the maximum number of free rooms that I can get in 0 to I? So we could build a segment tree, as we have discussed in the previous videos how to build a segment tree. The interesting part here comes as the query part, how we would be actually querying the part. Okay. So we would be actually querying upon the hotels, where we would be finding where we would be finding would find the hotel index where h of I is just greater than equal to the room that we want to check, and then the update would happen on the hotels. Okay, so let's see, like, code would give you a better understanding of how the query part is written and how we are updating them. Let's jump into the code. So yeah, so here is the input that we have taken, and we have made a segment tree for that. Now here we are finding the first index, that is for V rooms, first hotel index. So here is the query part that we have written. For query part, it's normal, simple. If tree node is less than V, then we are returning -1. And if start is equals to end, means we have find that node, then we have found a tree node greater than or equal to V. So we would return the start. Else we would be checking for the left maximum part, and then we would be going to the right maximum. If we found that, then we would be simply returning the index, and if index is equals to -1, then answer would be 0, like we don't find any hotel. Else we have find an hotel, then we would be reducing that hotels of that particular index -v, and would be updating our segment tree for that particular index, and update query would remain the same, like as we have written for the update. And when we would be completing this whole operation, and we would be printing index of I+1, which would give us the hotels that we are actually looking for. Now let's test this solution, whether it's working fine or not. Okay, so let me use the sample test case that is given. Yeah, it's working fine. Let's submit this problem. Test.cpp. Yeah, it should get, yeah, it get accepted. So in the next, this is how our segment tree would help us in actually optimizing the solution. So in the next video we would be discussing more of the segment range queries problem, and do subscribe the channel so you don't miss out on any of the problems that we solve. Thank you.